Hello and welcome back to a new challenge and coming deeper, learning deeper about the system Verilog sequential system and finance state machine, the basics to be able to create an AI chip and perform whatever matrix multiplication or whatever process needed to be done to build an AI accelerator that can, um, yeah, participate or help to run a machine learning on the processor itself. So um, let we, without further going, go directly into the learning of today, which should be the introduction to sequential logic and state machine. So here they are talking about um, they will explore how to analyze and plan complete sequential calculator design using advanced system Verilog concepts. Here is what we will be covering: sequential logic and storage. We need it, of course, for the calculator, and understanding how clocks elements store and process data over time, control and data path design, arithmetic, the architecting the flow of the data and the decision make logic. So this is the controlling, having a full control on the system and on the data path from where should it go to where, and conditional logic and looping, implementing operation and managing hardware structure efficiently, reusable code and parameterization, creating scalable and flexible design using function, tasks, and parameter. Let's go with the interesting dialogue with the AI. So the AI tell me like, great, let's begin with thinking about the core of any sequential design. The core of any sequential design is storage. So it looks like storage is something that is really needed and used for sequential design, right? In the context of sequential calculator, what role does storage play, and what are some common system Verilog constructs you would use to implement it? So let's answer first the question of what role does storage play. Say all the numbers coming from the user into the calculator should be stored to be used for the operation itself, right? Also, the history of cal- the history of calculated results can be achieved by um, by implementing um, storage for them, right? Basically, you have calculated 2 times 2 is 4, and then 2 times 5 is 10, and then 5 is 5 is 25. So we need to show the history 2, 10, 25. In order to achieve that, of course, you need a history, right? So the second part is about what are some common system Verilog construct you would use to implement it. Mm, I think I would use queues and arrays. Um, yeah, to hold the data. That's a great start. You have correctly identified that storage is crucial for both input numbers and history of results. Queues and arrays are indeed useful system value construct for holding data. All right. Now let's think specifically about sequential logic. When we talk about clocked storage in system Verilog for a sequential calculator, what kind of constructs are we typically referring to? And why are they essential for sequential operator? Maybe somebody in the chat can help me. If somebody can help me in the chat, I would be very happy. Um, mhm, mhm. For sequential operator. So, mm, what other? I think I don't know. What could be something clogged storage? Mm. So in my mind is FIFO, maybe maybe sequential FIFO. Sequential FIFO is excellent example for clogged storage. It's perfect for managing data flow in a specific order. Can you elaborate a bit on why FIFO or any clogged storage element is fundamental to sequential operation in calculator? What does the clogged aspect bring to the design? So it synchronizes the storage uh, and gives so and ensure the uh, flow of the data from one module to the other. So the two module perform their tasks the two module from module to the other. So like the system has full control with clock. The system can be um, controlled do to store data in exact moment. This helps to ensure that um, correct data is stored in the correct time, right? Excellent. You have hit on the key point. Synchronization and controlled data flow, right? The clock ensures that the data is stored and updated at precious, precious moments, which is critical for the reliable operation of any sequential circuit, including our calculator. This prevents race condition and ensure data integrity. Now that we have established the importance of clock storage, let's move into control and data path design. Okay. In a sequential calculator, how do the control unit and data path interact to perform an operation like addition or subtraction? Um, so the control unit knows when the data is available, then it enables the allow to perform calc operation on the correct data. That's a clear explanation of their interaction. Control unit acts like the brain, orchestrating when the data and how the data pass, which include data, performs its task. It ensures the right data is at the right place at the right time. Now let's dive a bit deeper into the control unit's role. What kind of logic or state machine concept would you typically use to design the control unit? For what kind of logic or state machine concept? Extra. Not optimal. Control units rule. What kind of logic or state machine concept would you typically use to design the control unit? Um, for sequential calculator, especially when considering multiple steps for an operation. I will use enum to cover all the states. Mm, for example, yeah, receiving data, debouncing, um, and then start operation and transfer results. Yeah. Okay. Mm, like I will use flags to share the situation of the calculator to the finite state machine module and um, use enable to control the whole system. This very solid approach using enum for state is excellent for readability and maintainability in system Verilog pencil machine. And the flags for status communication along with enable for control are fundamental for good. Now let's think about the actual operation. We will move on the conditional logic and loops. How would you use if case statement and potentially loops in system Verilog to implement the various arithmetic operation within your calculator data path guided by control unit? Okay, so uh, I will use case case operand all right, let's say conditional case of code, let's say mm, 1 2 bits of decimal 0, then this is addition, then result equals to operand 1 plus operand 2 equals to 1 times minus. Help you uh, all right, thanks. So now let's consider reusable code and parameterization. How can functions, tasks, and parameters in System Verilog help you create a more modular, flexible, and scalable? Functions, tasks, and parameters in System Verilog help you create a more modular, flexible, and scalable calculator design, especially if you want to easily change it bit wide and new operation. So basically, try to isolate different tasks and use dynamic arrays and queues. And use separate modules that can be reused. Isolating tasks into separate modules is key for usability, dynamic arrays, queues, offer flexibility, function tasks, and it's further by allowing you to encapsulate specific behavior or define configure aspects of your design. Can you give an example of how you might use a parameter to make your calculators data path more flexible, perhaps in terms of width of the number of handles? Yeah, okay. So define a parameter of width for certain data. Example, width operand equals to مثلا 8 bits, and use reuse the parameter in the in defining the logics. logic signal. Example logic uh, with operand -1 till 0 of operand 1. Give it to me, give it to me, give it to me. Excellent. That's a perfect example of how parameter can be used to find what's, yeah, correct. All right. All right. So, all right. So this was it for this step, and I will come again for the following tutorials and to get ourselves more deeper into sequential logic. Thank you so much for watching and see you in the next video.